Hi, and welcome to the 2.8 notes. We'll be talking about operating on functions and transformations. So if you look at example 1, it says if f of x equals 3x plus 2 and g of x equals 2x minus 7, what is f plus g of x? How do you represent this algebraically? So anytime it's saying let's add these two functions together, f plus g of x means let's take f of x and add it to g of x. So if I substitute those two functions in, this is really 3x plus 2, because that represents f of x. And then g of x was 2x minus 7, so I would say plus 2x minus 7. So now I can just combine like terms. So I would get 5x and then minus 5. So that's my final answer for f plus g of x. Look at example 2. It says if f of x equals 3 to the x power and g of x equals 5, what's f times g of x, and how would you represent this algebraically? So f times g of x means we're going to take f of x and we're going to multiply it to g of x. So I can substitute in f of x was 3 to the x power, and g of x was 5. Typically, when we rewrite this, we would put that constant in front. So I can say this is 5 times 3 to the x power. Be careful. You remember that exponent is only on the 3, so this does not combine to 15 to the x power. It's 5 times 3 to the x power. So that's f times g of x. If you look at example 3, it says f of x equals 2x minus 3 and g of x equals 4x minus 11. What is f minus g of x, and how would you represent this algebraically? So if I now want to subtract the two functions, you just have to be very careful with subtraction, because I'm going to take f of x and I'm going to subtract the entire function of g of x. So f of x was 2x minus 3. And g of x was 4x plus 11. I'm sorry, 4x minus 11. So I'm going to write minus, and I'm going to put parentheses here. It's going to be important because we are subtracting that entire function, so this is going to require some distributive property. So to simplify this expression, remember there's an invisible 1 in front, so we're going to have to distribute negative 1 to both terms. So this is really negative 4x, and then negative 1 times negative 11 is plus 11. So if I combine like terms, 2x minus 4x is negative 2x, and then negative 3 plus 11 would give me a positive 8. So that would be f minus g of x. If you look at example 4, it says if f of x is 2 to the x power and g of x is 3, what would f divided by g of x be, and how would you represent this algebraically? So if I had f divided by g of x, that means we're going to take f of x and we're going to divide it by g of x. So f of x was 2 to the x power and g of x was 3. So I would just say this is 2 to the x power over 3. So that would be my final answer for f divided by g of x. So this is all of the algebraic representations of these functions. Now let's look at some graphs. So example 5 says graph the following functions on the same axis, same set of axes. So the first one is f of x, which equals 3 to the x power. So I'm going to start at 0, and I'm going to go up 3 to the right one, or down 3 to the left one to get the points of my line. All right, go ahead, connect the dots, and then we are going to label this f of x. All right, let's change colors. So g of x is 3x plus 1. So here I'm going to start out at a positive 1, and I'm going to go up 3, excuse me, to the right one, up 3, to the right one, up 3. Let me change where that label is. To the right one, or I could go down 3 to the left one. So this red line represents that function g of x. And then the last one is h of x, which is 3x minus 5. So I'm going to start down here at negative 5, and I'm going to go up 3 to the right one. Up, excuse me, up 3 to the right one, up 3 to the right one, up 3 to the right one, or down 3 to the left one. All right, so now let's put the labels on here. So we know that the red line, that was g of x. That blue, excuse me, that blue line is f of x. And the pink is h of x. So it says describe the transformation from f of x to g of x. Well, what happened from that blue line to the red line? It looks like all we did was shift this up 1 unit. So we can say the transformation from f of x to g of x is the graph of f of x is shifted up 1 unit. When it says describe the transformation from g of x to h of x. Okay, so we're going to start with g of x. So I'm going to start by looking at that red line. And we're going to figure out how did we have to move to get to h of x. Well, from the red line, I'm just going to kind of look at it along the y-axis. How did it move to get to h of x, that pink line? I would have to move down 1, 2, 3, 4, 5, 6 units. If you look at the functions, how did I get from here to here? G of x to h of x. If you look at their y-intercepts, I had to subtract 6 units. So this would be the graph of g of x is shifted down 6 units. All right, let's look at the next example. It says, given the graph of f of x equals 2 to the x plus 1, graph the given function, or graph g of x equals f of x minus 5. So it has this given graph, this equation graphed already for us, 2x plus 1. And so this notation says, let's take f of x and let's shift it down. Let's shift it down 5 units. So let's shift f of x down 5 units. Well, an easy way to do this would be, remember, this is an exponential function, so it's going to have an asymptote. So if I look at where's my asymptote right now, it's at this equation y equals 1. So let's go ahead and shift that down 5 units. So that would move it down to y equals -4, because 1 minus 5 would be -4. Once I do that, I can go ahead and just pick a few points to shift down. So if I look at this order, this y-intercept, I'm going to move that down 5 units, so it end up at -3. If I look at this ordered pair, this is at 2, 9. So I'm going to move that down 5 units, so it'd be end up at 2, 4. Oh, I'm sorry, that is 3, 9. So we're going to shift it down to 3, 5. Okay, so that should be enough to kind of figure out the curve of my graph. Let me make the new points red. So if I connect my dots, the y-intercept, this is going to get close to that asymptote but never cross it. And then going towards infinity, it's going to hit that point and go upward. So this is my graph shifted down 5 units. So all we did was use the asymptote and then a couple points on the curve in order to shift it down. All right, looking at example 7, it says the graph of two functions f of x and g of x are shown. Write a rule for g of x in terms of f of x. So that means we're going to start, we want to figure out an equation, a rule for g of x in terms of f of x. So starting with f of x, how do I get to g of x? Well, an easy way to do this would just be to look at the intercepts here. So we have to figure out, is this going to be plus something, minus something? We're going to have to fill in this blank. So f of x looks like it's at the equation -x plus 4. And g of x is at -x plus 3. Excuse me, f of x is -x minus 4. So how did I get from -4 to 3? Well, I had to add 7. And if you can look at the graph, I'm going to go up 1, 2, 3, 4, 5, 6, 7. So that tells me that my rule is g of x equals f of x plus 7. So g of x equals f of x, because we took that f of x function and we just shifted it up 7 units. All right, that's it for transformations. Have a great day.